Okay, now we're going to find areas of regions in a plane using the definition. I'm going to write down the definition. You know you're going to need it. Let f be continuous and non-negative on an interval a to b. So it does something like this. From a to b. Here's my x-axis. All right. The area of the region bounded by the graph, f of x, the x-axis and the vertical lines a and b, is. The area is the limit as n approaches infinity of the summation as I goes from 1 to n of f of c sub I times delta x, where c sub I is between x I minus 1 and x sub I. So if I were to do a region like this, c sub I is here. Now usually you're going to want to pick c sub I as your left endpoint and your right endpoint. Delta x, we're going to use the regular interval is b minus a over n. So when you do these problems, the first thing I want you to write down is delta x equals b minus a divided by n, and plug in what your numbers are. Plug in b, plug in a, 2 and 1, 16 and 29, whatever. So write this down. The second thing you need to do is determine c sub I. Are you going to use a right endpoint, left endpoint, midpoint? How are you going to do this? The third thing I need you to do is to write down the definition. Right here. This is the definition exactly as is. All right. And I'm going to give you an example here in a minute. The fourth thing you need to write down is you need to plug in f sub ci and delta x. And then, of course, you just simply need to do the summation. And then finally, take the limit. These are much easier once you've seen a couple of them done. Let's find the area by the definition of limit for y equals x cubed between the x-axis and the vertical lines, y equals 0, and or x equals 0 and x equals 1. So it's right here. Okay. First thing, write down what is your delta x. Delta x equals b minus a over n. b is 1 minus 0 over n, so this is 1 over n. First thing you need to write down. Now we need to find c sub I. Let's go ahead and use, the easiest one to use is the right endpoint. Okay, so c sub I is just going to be 1 over n. Not 1 over n, excuse me, that's I over n. Because I want to start with 1 over n as my interval. Alright, so it's going to be I over n, 0 over n, 1 over n, 2 over n, that sort of thing. I'm not going to be this painfully slow on all of them, etc., until we get to, of course, n over n, which is 1. Alright, so now the next step, write down the word area equals the limit as n approaches infinity, and you're going to get to where you know this pretty well after you've done a couple of these problems. I equals 1 to n f c sub I delta x. You must write that down. That's worth a point on your quiz and on your test. So this is equal to the limit as n goes to infinity of the summation. I equals 1 to n. Now, what is f sub c sub I? I want you to go on and, okay, let's put this up here. F c sub I is equal to, everywhere I have a c in my function, I'm going to want to put, everywhere I have an x in my function, I'm going to put c sub I. So this is going to be I over n cubed. Now, if you need to do it up here, that's fine. You can just put it down here as long as you don't get yourself confused. So this is I divided by n cubed. So there's that. And then delta x is 1 over n. So let me pull all this out. Now you're going to be tempted to pull these ends out. You can't pull them out in front of the limit. You can pull the constant ends out in front of the sigma, but not in front of the limit. And how do I know that's what you're going to do? Well, how about this? That's what I always want to do. So this is 1 over n to the 4th times the sum, I equals 1 to n, of I cubed. Oh, this is not so bad. So this is the limit as n approaches infinity of 1 over n to the 4th. Now, remember I told you were going to have all these memorized. This is n squared times n plus 1 squared divided by 4. Okay? So now I'm going to, let's see, when you multiply all this mess out, you get 1 over 4 plus 1 over 2n plus 1 over 4 n squared. I'm going to show you all those painful steps. We've already done those. Now what happens? You take the limit as n goes to infinity. This is the limit as n approaches infinity of 1/4 plus the limit as n approaches infinity of 1 over 2n plus the limit as n approaches infinity of 1 over 4n squared. That's 0, 0, so your answer is 1/4. Now, what if we do this one right here? The area bounded by y equals 4 minus x squared, and the vertical lines x equals 1 and x equals 2. Well, again, excuse me, we know it's continuous, so let's give ourselves a partition. Delta x is delta x. Y'all ever have one of those days? I'm having one of those days. Okay, let's even switch colors here. Delta x equals b minus a over n. I want to make my pen a little bit thinner. I don't know why it popped over there. So this is 2 minus 1 over n, or 1 over n. Now let's choose the right endpoint. Alright, so if I come up here, this is my interval. It's not a very good interval. My slate is moving. I apologize. It's really hard to write on a moving object. All right. So if I divide this into n subintervals, then c sub I is going to be a plus I times delta x. Now, remember, delta x is 1 over n. So a is 1 plus I over n. So this is my c sub I. Now my function is 4 minus x squared. All right, so my f, c sub I, is going to be 4 minus ci squared, which is 4 minus 1 plus I over n squared. Now again, you can do this later on, but I think it just makes it a little easier to do all of these up front. All right, so next thing you need to do, we've got everything nicely defined. The area equals the limit as, I don't know why I keep wanting to write x today, n goes to infinity, of the summation I equals 1 to n, f c sub I delta x. So it's the limit as n approaches infinity, the summation I equals 1 to n. Now f c sub I is not attractive. 1 plus I over n squared, and delta x is 1 over n. I want to make sure you're seeing where I'm getting all of these terms. All right, this delta x is red, okay, and then this term right here is FCI. Now, it's just a matter of multiplying this ugly thing out. Okay, so this becomes the limit as n approaches infinity of, let's see, the summation I equals 1 to n. I'm going to go and pull out 1 over n out here. I'm just going to simplify this, 3 minus 2i over n minus I squared over n squared. So now we've just got the same summations we've had before, which is the limit as n approaches infinity of, I'm running out of space, so I'm just going to show you this part right here. 3 minus 1 plus 1 over n minus 1 over 3 plus 1 over 2n plus 1 over 6 n squared. So this is equal to 3 minus 1 minus 1/3, or I get a final area of 5/3. Okay, you give these a go, stop the tape, and come back, and we'll do one more example. What do you do when you're looking for an area bounded by the y-axis? The answer is you do the exact same thing that you already have done. And this time we're just simply going to do our partitions in the x direction. Now, if I do my, instead of delta x, I'm going to do delta y is b minus a over n. So that is 1 minus 0 over n, where we are integrating, we're looking at the area right here between 0 and 1. So this is 1 over n. And then CI, we're going to want to use CI as, I over n. So it's going to be F evaluated at I over n. So the area is equal to the limit as n approaches infinity of the summation I equal 1 to n F CI delta x, which is a limit as n approaches infinity, summation I equals 1 to n of I over n squared times 1 over n. So this is a limit as n approaches infinity of what? 1 over n cubed times the summation I equals 1 to n of I squared. So this is the limit as n approaches infinity of 1 over n cubed times n plus 1 to n plus 1 all over 6. Now if you do this, you get the limit as n approaches infinity of 1/3 plus 1 over 2n plus 1 over 6 n squared. That's a 3. Now you can just do it this way. This is equal to 1/3. So this area right here is 1/3, which tells you, since this whole area is 1, this area right here is 2/3. Now, give this one a go. Stop the video when you're done. Finish your homework.